Linear regression, part 2. Okay, in this video we're going to, rather than do it by technology, we're going to do it by calculation. Okay, this is not really required for the Math Studies exam, but it will be useful for the project. So just go back to our example below. In the table below are the results of 10 students, in both their mathematics and physics examinations. The teacher thinks there might be a relationship between the two. His hypothesis is a student who has mathematical ability also has ability in physics. Okay, what we're going to try to do is to calculate the y on x and the x on y regression lines by calculation rather than using technology. So if we go to the Excel spreadsheet that I've already prepared, and we first of all start filling in the gaps. So here I just want to have the sum of this column. So it's sum, bracket, and then all you need to do is scroll down, highlight that column, press enter. And then if we do this one as well, just scroll it across, it will do that one as well. Okay, I'm also going to need the mean. So enter this column and put equal average bracket and go all the way down like that again. Okay, click the sign there, that's good. Okay, and we'll do the same for this one. We could probably just scroll it across like that. Right, just put a little cross so it comes a little cross. No, look. Okay. It doesn't want to do it. Okay, we'll just do the same again. Equal average brackets, and we'll scroll down again, make sure we get them all, and press that sign. Okay, we'll get the other one. Okay, in this column we want to work out how far each thing is away from the mean. So in here I'm just going to put equals the 61, which is A2, minus, now I'm going to put this one here, which is the mean, okay, but because I don't want that to change when I scroll down, I'm going to have to put a dollar sign in here. Okay. Just check that's right, that looks okay. And then when this little plus, we'll just scroll down, and that will do it for all of them. Okay, unfortunately it's also taken down the sign here, so just so we put it back right, we'll just go back to borders, and put clear the border first, and then go back and we'll put back the original border, which is thick border. Okay, and then we'll do the same for this one. So this will be equal B2 minus this one. Put in the dollar sign. The dollar sign has the effect of keeping that the same when you scroll down. Okay, and scroll down. Okay, and again we've had the same problem as before. So what we'll do is we will put no border and thick border. Okay, this column here is going to be c squared. So in here I'm just going to put equal to c to little hat squared, enter, and then again go back to that one and then cross down like that. Okay, and we need to again just do the same thing with the border. So no border and thick border. Okay, I want to sum this one, so it's going to be equal to the sum scroll down this column like that, press the line and I'll sum that one, and then I'm going to do the same here. This is going to be equal to this one squared, enter, and let's scroll down here, get this one here. Okay, we're going to get rid of that border, so get rid of the border and big border. Okay, and then we'll just do the sum here, equal to the sum. Scroll down. Let's see, on that. Okay, and this one here, I just want to do equal this one times, now times will make the sound with that symbol. This one. Okay, we're going to scroll down. Okay. Again, get rid of the border. And thick border. And this is going to be equal to the sum of that one. Okay, I'll just tidy this up a little bit here. Just want to center this, and we'll have the same font, which is Arial, which is what I was using. It was Arial, and it was 16 to make it nice stand out. Okay, there's my table, which I can save and then put it into another document. Okay, so reproducing the table, that's the table I just reproduced. So you can import it into a Word document or Excel, into a PowerPoint. There's the sums. Okay, so the mean would be adding them all up, which is 552 divided by 10, which is 55.2. This one's 532. And therefore the mean of y is going to be 532 divided by 10, which is 53.2. There is all that column. There's that column. Then we square them. I sum that, and I get that number there. And I now can work out the variance of x, which is the sum of how far each file is away from the mean divided by n, which is 7091.60 divided by 10, which gives me 709.16. And I do the same for the y squared, how far they're away, and get that number, and therefore I can get the variance of y. So it's going to be sum of how far each thing is away from y squared. It's squared because some of them are positive and some of them are negative, if you remember. Get that number, 6,191.60 divided by 10, which is 619.16. And we've got this new thing called the covariance, so that's the sum of that column, which is 6,266.60, and so it will be 266.0 divided by 10, which is that. Now, I can use the TI-SPA calculator to actually calculate some of these values as well. So, let's escape this for a minute. We'll go back to this. We'll just copy these two columns. Okay, you have to probably enter them in manually, your calculator. Go to the TI-SPA calculator, turn it on and go for a spreadsheet. I can do right click, but you can paste, put my data in. Now if I just click on that one. If I do menu for statistics, stat calculations, and now go to what's known as two variable statistics. It's two variables because we have two variables here, x and y. Enter. make the first list be A, the second list be B, that we've done before. Okay, and we'll put the results in C, so we don't overwrite anything. Okay, we want the frequencies for each of these lists to be 1. Okay, and then we press OK. We get a load of statistics here. Okay, we get the mean of x, sum of x squared. We get the standard deviation, which we could square and get the variance. The number of terms in the in the lists. The mean of the y data, the sum of y squared. The variance, sum of x, y's. The correlation coefficient, which we talked about before, so notice the same value. What else we've got down here? Anything any more interesting? And we've got some of those values that we've just calculated, 7,091. Okay, so we've got some of these, some things that we've just calculated. Right, okay. So leaving that, going back to the PowerPoint. So the variance of x, so that there's a screenshot of what we just done. The alternative formula is this one here, the sum of x squared over n minus x squared. So I can get the sum of x squared, which is there. I know the 10 already, and I've already calculated the mean. So I can get the numbers, which will look good in the project, rather than just getting numbers from a calculator, and put them in. And if I did the calculation, I'd get exactly the same values I got before if I used this formula. And I can do it for y as well. Okay, doing it for y, we've got the mean of y here, and the sum of y squared. Okay, and putting the numbers in. So these are the numbers. Minus that squared, and I know there's a 10 already in there. Okay, we don't take the square root this time because we're asked to calculate the variance of each thing. Okay, remember the variance is the standard deviation squared. And the same for the covariance. It's this formula. Okay, if you scroll further down your calculator screen, you get this value here of the sum of x, y. Alright, we already have the means of these two from the calculator. Putting the numbers in, we get that, and we get that value, the same values as we've got before. Alright, having done the two variable stats calculation, we can actually find the actual value of the variance with the calculator, which is the standard deviation squared. And this can be shown using the variance menu on the calculator. So I'll just show you how to do that. Will be the screenshot that we'll get in a minute. Okay, so I'll just show you how to do that. We go into our calculator, press on. Right, you have to have done that previous calculation on the calculator first. Press this one here. Okay, and there's this function here called variable, and what we need to do is scroll down until we find the standard deviation, and we need to square it to get the variance. Okay. Okay, and do it again for the y. Don't forget we square it, so we can actually get those values if we want from our calculator. Okay. Those are all the important values which I've just calculated, and now we're going to calculate the regression line. So we do y on x, which is this form, y is equal to ax plus b, and it's calculated using this formula here. Okay, this one is the covariance, and this is the variance of x. This is the mean of y, and this is the mean of x. So putting the numbers in, we get that. So it's y minus 53.2 is equal to the covariance divided by the variance of x, okay, and x minus the mean of x. if we do this calculation first on our calculator, we get this. Okay, the little dots there are to say that I haven't put down the full calculator value, but I still have the calculator value. And the next thing to do is to take that and multiply it by x, and that and multiply it by 55.2. So we end up with y minus 53.2 is equal to 0.8836. I still have the value in the calculator, minus 46.12. And the final thing is to take this, okay, and add it to this side. And then we get the regression line of y on x. I've given the answer here correct to 3 significant figures. So this is the calculation that should appear in your project. Alright, for the regression line x on y, which has this form, exactly the same thing, but the formula changes, okay? Basically, these two interchange, and the variance is now the variance of y. Okay, putting in the relevant numbers, we get that. Do the same before, we work this bit out first, we get this number here, then multiply this by this, and this by this, we get this. The 3 dots mean I haven't written down the full value. So these 3 dots here mean I haven't written down the full value. And the final step is to take that to the other side. We get that calculation there. If we plot both lines on a scatter diagram, there we are, we've got that. Now if you were going to do the x and y manually, then you'd have to rearrange it. So it looks like that. And then we get the graphs that we've got before. Notice that both points go through the mean. Okay, that's a good check for you to see if you've got them right. Okay, nicely labelled axes. Okay, and you can use technology to draw this graph in your project, but a title for the graph. Okay, so all the things that you need to put in. My advice is to use technology. This particular one was actually drawn using Excel. Okay, so label the graphs, y on x, x on y. You can actually put the equation, there's the means. Okay, correlation. We need a way to determine whether there is linear correlation or not. So we need to calculate what's known as the product moment correlation coefficient. This is given by this formula. This is the covariance, but this one is actually the standard deviation. So we just need to take the square root of the number we've obtained before, and this is the standard deviation of y. So we just take the square root of the variance number that we've obtained before. Okay, these are the formulas, so we've just added in a square root sign on these two. Okay, let's just have a look at these 5 sets of data to see if we can see anything about the degree of scatter of the 2 sets of data. Okay, this is table 1. Okay, if we were to calculate the y on x and x on y regression lines, we get those numbers. The product moment correlation coefficient would be that. Okay, we can see that the 2 lines pretty well coincide. Okay, but we've got something different. When this one gets bigger, this one decreases. This is what's known as, here we notice we have 2 regression lines, y on x and x on y, nearly coincide, so that as the x data increases, the y data decreases. The value of r is minus 0.990, which is close to minus 1, so this is what we call strong negative linear correlation. Table 2. Here's the 2 regression lines. Let's see, we've got minus 0.529. We've got the 2 lines there a bit wider apart. We've got some sort of negative correlation here. In table 2, the 2 regression lines are further apart. Though there's weak negative linear correlation, the value of r is minus 0.529, which is getting closer to 0. Table 3, got that data there. Y on X and X on Y lines. The product moment correlation coefficient is that, very, very, very close to 0. There's my graph. In table 3, the two regression lines are virtually perpendicular. There is no linear correlation. The value of R is minus 0.000548, which is very close to 0. Table 4, there's my data. There are my Y on X and X on Y lines. There's the product moment correlation coefficient. There's the graphs. Here we've got some sort of positive correlation. In table 4, the two regression lines are further apart, but we notice that the X data increases, the Y data increases. This is what's known as weak positive linear correlation. The value of R is 0.612 and is moving away from 0 and getting closer to 1. Table 5, there's my data. There are my regression lines, X on Y and Y on X. We've got 0.99 as the value for R. We've got this value here. Okay, the lines virtually coincide. In table 5, we notice that the two regression lines, Y on X and X on Y, nearly coincide, and as the X data increases, the Y data increases. The value of R is 0.990. This is what's known as strong positive linear correlation. The value of R determines the degree of linear scatter on the two sets of data, and it's always between -1 and 1. R is equal to 1 indicates perfect negative linear correlation. R is 0 indicates that the data has no linear correlation, and R is equal to 1 indicates that the data will have perfect positive linear correlation. R is called the product moment correlation coefficient. Returning to our example, so there's the graph of our example. This is all the numbers that we put in. This value we've calculated before. This value we've calculated, we just need to take the square root of it. This value we've calculated, this is the standard deviation of Y, standard deviation of X, the covariance, and then we get this value of 0.946. That's how it's calculated. So we can conclude that as R is close to 1, the results show that his hypothesis, a student has mathematical ability, also has ability in physics, might be true. There is a picture of our graph that we actually drew with autograph. Okay, that's some help there for your project, so that your project actually will have some mathematics in it. I hope you find that useful.